Number 10, it asks us to find the arc length of the cardioid. X is equal to r theta minus sine theta. Y equals r cosine theta. 0 is less than or equal to theta is less than or equal to 2 pi. So those are our bounds. We need the arc length formula first. Arc length is equal to integral from a to b, root of the partial derivative of x, so dx over d theta squared, plus dy over d theta squared, d theta. We're given that x theta is equal to r theta minus sine theta. We're also given that y is equal to r cosine theta. And that the derivative of x over d theta, the derivative of r times theta minus sine theta is 1 minus cosine theta. And the derivative of y over d theta is equal to, r is a constant, so it becomes 1. Negative, oh, r is still there. My bad. It's equal to r times sine theta. Now plug these back into the formula with limits that were given in the problem 0 to 2 pi. Square root of r times 1 minus cosine theta squared plus r minus sine theta squared, d theta. Simplifying this, we get square root of r squared minus r squared cosine squared theta plus r squared sine squared theta, d theta. So we could actually take an r squared out of everything here, and the square and the radical cancels this out, so there would only be one r going from here to outside the integral, with the rest being left to 1 minus cosine squared theta plus sine squared theta, d theta. This being an identity, I distributed the square a little preemptively, but we would need to FOIL this term here, which would give us 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta, d theta. This cosine squared theta plus sine squared theta being equal to 1, added to this one would give us 2 minus 2 cosine theta d theta, which would then you could factor out the 2, which would give you 1 minus cosine theta d theta. You could then take out the root 2 in the integral and be left with root of 1 minus cosine theta d theta. And this is actually a half angle identity, so this would then turn into sine squared theta over 2 d theta. That's square and this root cancel. And then there's supposed to be another 2 in here as well. Okay, going back a step. This radical 2 also comes out of the integral, and this root 2 now becomes a normal 2. This square cancels with this radical. So now you're left with sine theta over 2, which then turns, because you're taking the integral, turns into -2 cosine theta over 2. Going from limits 0 to 2 pi. Written out a little more, we get 2r. This -2 also comes out because it's a constant. -4r multiplied into cosine 2 pi in the parentheses turns into pi minus cosine 0 over 2 turns into 0. Cosine of 0 is 1, and cosine of pi is -1. So then you have a -2 multiplied by -4r, which gives you 8r. And that is the arc length of the cardioid. Last problem is going to come in 2 parts, and we're almost at the